All right, so this is week 2 of our rock unit. Right now, you should have your Cornell style note sheet out in front of you. Draw those 3 lines. The title on the very top should be Rock Cycle and Rock Layers. And then on the very top line, we're going to put our question, which is, how does the ground end up like that? And you could point to any section of ground as your section of ground that you need to determine that. So during the course of this lesson, we're going to be listening for these key questions. As always, don't write these down. I just want you to look at them and read them, kind of put them in the back of your head so you can be listening for the answer. But we want to know how each of the rock types are created. What are the different steps of the rock cycle? What is strata? And how do rock layers form? So the first thing you need to know is all rocks go through numerous physical and chemical changes. The physical changes are caused by things that are, touchable, and chemical changes usually typically happen at the subatomic level with the atoms. All of these changes put together, if you add them all up and put them together, they are called the rock cycle, which moves in a circle. And what that means is there's no beginning and no end. And it could be said that every single rock will eventually be another type of rock at some point. Now, one key thing that you may want to write down about the rock cycle as you're making a note of the rock cycle, it's important to understand this occurs over millions of years. So if you're holding a sedimentary rock in your hand, it's not like it was just made yesterday. It's probably been there, at the very least, thousands, if not tens or hundreds of thousands of years. So we're talking about a completely different time scale than maybe what you're used to thinking about. So let's get started with this video. It's kind of an introduction, and then we'll get into some more depth.
We're talking about rocks on this episode. Geology. In fact, rock types.
Rock types.
Probably sitting there now thinking, why do I need to learn about rock types? Why did I click this video? Well, I'll tell you, rocks are cool. Even if you're not going to be a geologist, it's really important to know what you're looking at. For instance, we do a lot of rock climbing, we do a lot of adventuring. We went last week to Red River Gorge in Kentucky, world famous for its rock climbing. And you talk to any rock climber there, they're going to know what rocks they're looking at.
It's composed of Corbin sandstone, which is a sedimentary rock.
Now besides that, it makes you sound smart in general because you look at a rock face, especially beautiful arches or deep canyons, and people, very commonly ask, how did this form? Where were these rocks before, right? And so if you know a little bit about rocks, you can take a stab at that answer, and even if you're not right, you sound pretty smart doing it. But first, you gotta know rock types.
The igneous.
The igneous.
Now start with the igneous because it's the natural place to start. It's where new rock is formed from molten magma. You see, a couple years ago, Hale and I went to Hawaii. We marched out along the coast, the big island of Hawaii, and we were able to see new rock forming when none existed before.
Glowing behind us, new earth being made.
It's lava forming igneous rock.
When that lava, or magma in some cases, cools, it becomes an igneous rock.
Right there. If you were wondering how rocks were formed, there you go.
Now, when magma cools slowly, it forms really beautiful crystals. The slower it forms, the bigger the crystals, right? So if you were, say, climb the Grand Tetons, which we did last month, you're able to see these giant crystals on the surface of the rock, and it's just awesome. Moving on, sedimentary rock.
Sedimentary rock.
Sedimentary rock is really cool because every sedimentary rock came very clearly from other rock, and you can almost look at the grains and see it because that rock basically got cemented together from the parts of other rocks. Got cemented together. How cool is that? And maybe the coolest manifestation we've seen is when we went through the Grand Canyon. And not only are you seeing these giant cliffs of exposed sedimentary rock that, are going back millions and millions of years, but you're actually on a river that is actively moving sediment away and depositing it somewhere else.
Metamorphic rock.
Metamorphic rock.
The metamorphic rock is just when you take any of the other rocks and you put them under heat and pressure and you twist them and meld them up. Now here's a rock climbing place in Golden, Colorado that we like to climb that's metamorphic rock. one of the coolest places. First, to get to it, you gotta climb up a tree and zip over on this cable, and then you're climbing up the wall. And one of the things you'll notice is that when you're climbing the wall, the whole wall is like twisted and melded up. And that is metamorphic rock because it used to be granite. The reason for me wanting to tell you about rock types is just to get across the point that rocks change. You see, if you were to look at a rock cycle, you would see that any of the rocks, if they get broken down into little pieces, they can reform into sedimentary rock. If you take any of the rock types and you heat them up until they become molten magma, when they cool, they'll become igneous rock. And then likewise, if you were to take any of those forms and put a lot of heat and pressure on them, they will become metamorphic rock. So almost every rock can become another rock in this giant cool rock cycle. So there you have it. Rocks are pretty cool, especially the more you know about them.
All right, so go ahead and draw this picture. I would say don't worry about the labels yet. You may want to go back and label them. You can label it right now if you want to. But go ahead and draw that because that is the rock cycle and you will need to identify the different parts of it eventually. So looking at the top, that blob of orange at the top would be lava or magma, molten rock, basically. And then to the left, as you go kind of counterclockwise, that's igneous. And then beneath that are some sediments, and we'll talk about what sediments are in a little bit. And then lower right is sedimentary rock. And then above that is metamorphic and then back to magma. And then you have some arrows kind of going all crisscrossing in the middle. So if I'm going to move on here in a second, if I go too fast or if I went too fast, you can either pause the video now to finish your drawing, or you can go back and re-watch this to finish up the drawing. But there are some words on this slide we need to kind of clarify what they mean. We're not going to talk about melting because I think you know what that is, but the other steps we are going to. So let's go through here. Now, each one of these little terms, you don't need a ton of information, but you do need to know the basics. So we're going to kind of walk through these. It's pretty self-explanatory, but I just want to make sure that there's no confusion. So crystallization. You'll sometimes see the word cooling as it relates to the creation of igneous. And this basically just means molten rock turning solid. So you get molten rock that becomes igneous. That's what crystallization is. You will actually sometimes see the word cooling, or you'll even see them both, cooling / crystallization. And so minerals, all of the chemicals, all of the loose ions that were in the rock, given enough time, start to form those lattices that we've learned so much about, those patterns, those repeating patterns. And as you know now, the longer you give an igneous rock to form, the more crystals you'll get. Next, you have weathering and erosion. And I put those together so you didn't have to do two terms in your notes, but they basically mean the same thing. Weathering is what happens to a small rock, and erosion is what happens to kind of on a bigger scale, on an entire like area. And so, but basically they mean the same thing. It's anytime you break down or dissolve a larger rock into smaller pieces. The breakdown part could be done by a number of things: water, wind, ice from a glacier, you name it. You know, sometimes even a mudslide or avalanche. And then the dissolving part, it's pretty obvious, but when you dissolve something, it's in water. And so typically when you're dissolving things, it's going to be underwater. Deposition, and what that means is once you have sediment, and we're going to get to sediment in just a second, but once you have sediment, it's anytime they're added to a landmass. So weathering and erosion kind of leads to deposition. If I take a rock and I scrape the top of it off, all of the like dust and dirt that fall off that rock will fall on the ground. And now that they're on the ground, they were deposited on the ground. So the word deposition comes from the word deposit. And so you could think of also, if you think about, you go to your bank, and if you deposit your paycheck, you're adding money to your bank account, right? So think of deposition, if you want to off to the side, put, this is where you add sediment somewhere. And then what is sediment? So the word sediment just means any solid material that's moved to a new location on Earth. Okay. So it could be as small as a grain of sand or as big as a boulder, but they're all called sediment. So if I take two rocks and I set them on my desk, kind of technically they are sediment, but typically what we would normally think of sediment is where you take pieces, little bits off of a rock, wash them downstream or move them somewhere else. Those are called sediment. So for most students, when they hear that word sediment, they think dirt. You could also think soil. If you go out in your backyard, put your hand on the ground, pick up some sand and dirt, you'll be picking up sediment. Compaction. If you have in your house, some people in their house, like in their kitchen, have something called a trash compactor, and it just means adding pressure to the sediment. So I want you to think of like a sandcastle. If you're building a sandcastle and you kind of pat it down with your hand, you smush it down. Why are you doing that? Well, you're doing it to hold it together, right? If you're building a sandcastle at the beach and you just kind of scoop the sand up with your hand, it will fall apart. But if you smush it together and make, like a clump, like a dirt clump, it sticks together. And so that's compaction. Cementation, it's the root of that word is the word cement. And you probably have heard of cement as a mix or a noun, like the sidewalk is made of cement, right? It's actually a process. And so when you cement things together, you're basically putting them together so they don't come apart. You may have, when you were in elementary school, you may have used something called rubber cement, which is similar to a glue, but basically cementation just means putting stuff together. Now, in terms of geology, cementation is really interesting. And if you continue your education into college, they'll talk about it in more detail, I'm sure. But cementation is just where dissolved materials from the sediments crystallize together. So if you get multiple minerals all kind of forming crystals in the exact same place under intense pressure, they literally get tangled together is the way it's described to me. And so after this happens, billions of times at the subatomic level, they get tied together and stuck, and you get a sedimentary rock. So it's really interesting, the process of cementation. And then lastly, you have metamorphism. And metamorphism is exactly what it sounds like, but you do need to know that there's two types. And metamorphism in general just means when you change the minerals in the ground due to heat and pressure. Now, that is causing metamorphic rock, but there's actually different types of metamorphism. You could have contact metamorphism, which just means magma touched the rock and magma is so hot it started to melt it, but then it didn't melt. You could have regional metamorphism, which is mostly from pressure. That would be how you would basically make foliated rock. The contact one would be non-foliated typically. Or you can actually have something called dynamic metamorphism, which is really interesting because it's caused by a fault. And so what you have is, especially in California, along the San Andreas, you have sedimentary rock, but right at the fault lines that we have, if they're under intense stress, like a lot of force over millions of years, they can change those sedimentary rocks into metamorphic near the surface. As you know from last week, typically metamorphic rocks are formed miles and miles down. They're under intense pressure from the rocks above and also from the lava beneath, or the magma beneath. But you can actually, with dynamic metamorphism, you can get some metamorphic rocks closer to the surface, which is why you have some in California. So this gentleman right here will summarize all that for you. And he's going to show you, I think, a demonstration with starburst.
The first kind of rock we're going to learn about is sedimentary rock.
On top of mountains, it can get pretty windy and rainy. And did you know that this wind and rain can chip away tiny pieces of rocks and dirt away from the mountain? These tiny pieces of rocks and dirt are carried by water down streams to rivers, finally reaching oceans and lakes where they sink down to the bottom. We call these tiny rocks and dirt that sink down to the bottom sediment. Over time, more rocks and dirt sink on top of them. Then more sink on top of them. Then more on top of them. After a long time,
1 million, zillion, jillion, dillion, cotillion times later,
things start to get heavy for the rocks and dirt at the very bottom. These layers are squeezed together harder and harder until eventually sedimentary rock is formed. Now using these starbursts, I'm going to show you the rock cycle. So now I'm just going to cut up the starburst into tiny little rocks, which we'll then use to make our sedimentary rock. Okay, so our sedimentary rock has now been formed. This has been made of many smaller pieces of rocks and dirt, all squeezed together to form one hard rock. Sometimes these layers of rocks and dirt can be very clearly seen within the sedimentary rock formation. Although all rocks are pretty hard, sedimentary rock is probably the weakest out of the three types of rocks. Examples of sedimentary rock include sandstone, mudstone, limestone, shale, and even coal. And the next type of rock we're going to learn about is metamorphic rock. Sometimes these layers of rocks and dirt deep underground become close to molten hot magma. To add a little bit of heat to this rock, I'm going to use a hairdryer. The heat of the magma combined with the huge pressure of all of the layers of rocks above can cause the rocks at the bottom to be chemically changed into metamorphic rock. But this also takes a super long time. The next type of rock we're going to learn about is igneous rock. Igneous rock is formed when rocks become so hot that they melt and turn to liquid. We call them molten rocks. Molten rock that is underground is called magma, and molten rock that comes out of the ground is called lava. When the magma or lava cools down again, it hardens and forms igneous rock. Take a look at my starburst. When I heat them, they begin to melt and form molten rock. Then, when they cool down again, they harden to form igneous rock. Then once again, over a super long time, this igneous rock is chipped away by the wind and rain. These tiny pieces of rocks and dirt are then once again carried away by the water from streams to rivers to lakes and oceans, where they sink down to the bottom. And the cycle begins all over again. We call this the rock cycle.
All right. But here's the thing. As all those things are happening, they are happening in layers. Now, when we talk about these layers, this is different than what you learned about in the last unit about the layers of the earth. We're not talking about crust, mantle, core, and all that. We are literally staying right towards the surface within a few miles of the top of the earth or near the surface of the earth. So keep that in mind. First of all, before you go any further, we're not talking about the mantle here. We are staying completely in the crust and maybe the very top of the upper mantle, meaning but we're all staying in the lithosphere. So that's number one. All right. So the layers of the ground tell us what was going on around that time. And we'll give you some examples here. But first of all, if you see limestone, limestone only forms in water. So if you see a layer of limestone, it was once at the bottom of an ocean. And so you have a pretty good idea of what was happening at that time. If you find an igneous rock, you know there was once magma in the area. So those are two examples. Now, what are the rock layers? Here they are. First of all, if you get sedimentary rock layers all together, they are called strata. You definitely need that word. It's going to start to become very important, especially next week. Now, before we move on, the word strata is actually plural. It means more than one. If you want to know, one layer of rock would be called a stratum, but very rarely do people even use that word. So when you talk about the layers together, you call them strata. Now, these are very important because they are the only ones that can contain fossils. You definitely want to include that as well. So wherever you put strata in your notes, put in there that they often contain fossils. So when you find a layer of strata, that means there was water there at some point because sediment settled to the bottom, and I'll show you that on the next slide. Now, igneous rock layers can either be from lava flows on the surface, and that's pretty obvious, so we're not going to spend time on that, but they can be as part of intrusions underground. So if you think of the word intrusion, think of the word inside, or you could think of intruder. And you can kind of, if you've heard that word before, you can kind of see where we're going with that. But this is where igneous rock basically forces its way into a sedimentary layer and then crystallizes or cools. The problem with that is you cannot find a fossil there. And it's pretty obvious why, but lava or magma is much, much, much too hot for the fossils to survive. They would be burned up. So intrusions actually are not incredibly useful to study history. Now, metamorphic layers don't really receive a name. They're so far underground, except for tiny, small little areas near magma intrusions. So we really don't have a fancy name for a metamorphic layer. Now, let's start with sedimentary. This is how basically sedimentary layers of strata form. So if you start, this goes in order. So start in the upper left at number 1. And what happens is sediments wind up in the water. Usually they get washed into the water from the land through a river. Sometimes, wind will push it in. Sometimes a glacier will push strata into the water. Glaciers usually happen during ice ages. Now, a layer gets deposited, that brown layer that you see in number 1. Now look at number 2, a different type of sediment, that more tan or yellowish color of dirt gets pushed down on top of the brown layer above. Now you have 2 layers of strata. And then look at number 3. Now you have even more. And then look at number 4. You get another layer on top, and now the water is actually starting to go away. And as the water goes away, the salt crystals glue the layers together. Remember, we talked about that. They cement together because the crystals literally start to entwine and tangle with each other. And over many thousands and thousands of years, this does not happen fast, but over thousands of years, you wind up with sedimentary layers called strata. And then here's how igneous intrusions work. And I don't know that you need all of this picture, but you should probably take a look at it. But what you have down there is a magma chamber, as you can see, and it shoots off in other directions. Now, it can make a sill, which is basically a flat layer of igneous rock that is in between 2 layers of strata, typically. It's typically parallel with the surface. And then you have something called a dike. And what that means is it forces its way vertically. And when I say vertically, I mean straight up and down. And it usually breaks a layer of strata in half or splits it open and fills that gap. You could also have these batholiths, which it's a fancy science word, just means a big bunch of igneous rock that's all pooled together. And as you can see, anything on the surface is called a flow. So if I was walking in Hawaii and I came across the lava that I showed you in that photo of me standing on that lava flow, we would call that a flow because it made it to the surface. So that's how igneous intrusions work. And here's a video to help you understand.
The Yorkshire Dales National Park covers 1,500 square kilometres. Different parts of the park have different surface rocks. Why is this? 350 million years ago, it was under a warm, clear tropical ocean. Skeletons of sea creatures collected in the bottom in layers. The sea became shallow and silty mud was laid down. Under its weight, the sediments were squeezed into limestone that cracked into vertical joints. Later, rivers washed sand into the sea. The mud hardened into shales, the sand into grit and sandstones. Then layers of younger rock built up on top. Earth movements cracked the whole crust along fault lines, and all this time erosion was shaping an undulating surface. Then in the last few million years, great ice sheets scraped away at the landscape. As they melted, they left sharpened peaks in some places and bare limestone in others. And the meltwater continued to run off over the fault line, cutting deep coves and gorges. Since the last ice age, humans have changed the landscape too. If people hadn't settled here, this would be ash forest.
All right. So this is an example of what you might see if you could cut into the ground with like a knife and look at the ground. So on the top, you can see that tree right there. And pretty obviously that tree is the surface. And directly below the tree, you have some sediment, probably some soil. And then after that, you have varying layers of strata. So if you look at the numbers, we're probably looking at 1, 2, 8, 4, 5, 6, 7, all layers of strata. But if you look at number 3 is an igneous intrusion. And so what happened was you had a magma pool right there at that kind of number 3 spot. And it was under a lot of pressure and it forced its way into a weak spot and forced its way all the way up to the surface. And actually it looks like this one kind of made it almost all the way to the top. Now, what you're seeing there with those two, do you see on the very top of the igneous intrusion, those two little peaks right there? Those aren't lava flows because they're not flowing out from there. They stayed there. So what happened was the magma forced its way up. It formed those two little kind of peaks, and then the sediment, the dirt around them washed away or was eroded and weathered away and exposed them to the air so you could see them. Those would not be considered lava flows because they did not lay flat and sit down on the sediment. So the problem with reading rock layers, and you kind of saw it in that video, they don't always lay flat. Intrusions are always younger than the rock surrounding them because they would not be there if the layer didn't already exist, as I mentioned. And the other problem scientists have when they're looking at layers is the lithosphere moves. It creates faults. And when those faults rip layers apart, they create these things called folds or places in rock layers where the rock layers have been disturbed. So these are examples of folds. And quite literally, this is a place where if you imagine a piece of paper and if you lay it flat on your desk and then you take your two hands and squeeze the sides of the paper, the middle of the paper will buckle. It will fold. And so you're literally seeing that here. These are sedimentary rock layers or strata that have been pushed together with such force, they've started to fold and create bends in the strata. You can actually sometimes get some metamorphism going on if there's enough pressure. So this gentleman right here is going to talk about folds.
Folds are a type of rock structure in which the rock layers have been buckled and bent such that they now form dome and valley-shaped features. A bit like me deforming this foam block. Folds can occur on more or less any scale, from a few centimetres to tens of kilometres. These cliffs show spectacular examples of folding, in which the rock layers have been distorted by the gradual action of pressures in the Earth's crust, such that they now look a bit like a rucked-up carpet. It will be important for several reasons for RWM to understand whether a potential site for a geological disposal facility, or a GDF, contains folds. First, we need to demonstrate that the underground geology can act as a natural barrier, preventing or slowing down the movement of water, gases and other fluids from a GDF toward the surface. Folding involves bending rock layers, which often respond by breaking or fracturing. We need to avoid areas of rocks with fractures because they can provide pathways along which fluids move more easily. Second, the rock layers in large folds are tilted, often quite steeply, making it more difficult to construct the underground tunnels and vaults of a GDF. RWM will use geophysical surveying and boreholes to investigate underground folds in great detail.
All right, so right now you should ask yourself, do you know how each of the rock types is created? Do you know all the steps of the rock cycle and could you recreate it? What is strata? And do you know how the different rock layers form? So what you should do right now is take your notes, set them off to the side, go do something else for at least a few minutes, hopefully longer. Then you come back and you try to do your summary. Now, please make sure you do the summary, because if you cannot do the summary, it means you don't have all the information, and you may have to rewatch some portions, or you may have to go back through the notes and find out what to put in the summary. Make sure there's detail, specifically state what you learned. And then once you have your summary done, you are finished with this lesson. And as always, I thank you for your attention.